I've got question 53 up. Let me know if you cannot see 53 on your screen. These are all
Okay.
optimization problems, and you'll see these again in calculus. So you just use a different technique to solve them. So we actually already read through the problem. It's a rectangular track. Okay, and then it's got two semicircles on either side. Okay, and they tell you that the perimeter is 200 meters. Okay, X represent the length, and Y represents the width here. So that's part A. Nothing too I don't know, nothing too unusual about part A. Part B is where it starts getting interesting. They want you to determine the radius of the semicircle. Part B. So part B, determine the radius of the semicircle. And so the radius is y divided by 2, because it's a semicircle and the diameter is y. Determine the distance in terms of y around the inside of the two semicircular parts. So they're asking for the distance around. So that's the perimeter of the circle. The perimeter of a circle is the circumference. That's 2 pi r. That's 2 pi times y over 2, which is just pi times y. Okay. All right, so part C, this is actually where you would actually start this question like in a calculus class. They're really walking you through the steps of this so that you see what you have to do here. You actually have to just write two equations, one for perimeter and one for area. Here they're asking you to write the perimeter, like going all the way around the track. Okay, so all the way around the track, just pick a starting point here, like maybe that's where you're starting. So that's X, this part right here, X, and then this part right here. So it's X plus X. And then because we found the perimeter of the whole circle, if you put these two together, you get the whole circle, you say plus pi y. So that simplifies to 2x plus pi y for part C. Part D. Again, if anything is unclear here, interrupt me and I'll do a better job of explaining it. So the area inside the track. So you've got to go back to this picture again. So there's a rectangle here, and the area of the rectangle is x times y. So it's x times y, plus you have the area of the circle. So there's two semicircles, that makes a whole circle. We know that the area of a circle is pi r squared, and the radius is y over 2. Okay, so this is xy plus pi y squared over 4. Now, importantly, it says here it's only a function of x. Okay, and that's why you did this part previously. So around the track they said was 200 right here. So we're going to take this equation, we're going to bring it down here, and you either solve for x or y, depending on the question. Now, because they want it only in terms of x, you're going to solve it for y, because then it'll only have a y in it. So solving this for y equals 200 minus 2x over pi. Okay, so this substitutes in for y and for that y there. And you get an area as a function of x times 200 minus 2x over pi plus pi, 200 minus 2x over pi squared all over 4. Maybe I'll put that there. And that's part D. Okay. Now, you're using a calculator, thank goodness. In calculus, you will do this by hand, which may seem impossible at the moment, but it truly isn't as bad as it looks when you do it. So they want you to graph this thing. You guys have graphing calculators. So what I'm going to do is I'm going to graph this in Desmos, print the figure in here and try and give you a window to work with. Just be very careful. You want to make sure these go in the numerator. You don't have to simplify this. You don't have to square anything. You just have to make sure you get all the symbols there right. So give me a moment here to get my graph. If you guys want to, you can graph it now or graph it later. All right. So I got that graph. Let's see if we can find it. That doesn't look right. Okay. My graph doesn't look quite right. Let me just check here. 200 minus 2x over pi. X plus x. 2 pi r is the circumference there. Pi y. Okay. And what are we trying to do here? What are we trying to maximize? We're missing a negative. That's part of the problem here. All right. Are you guys graphing this? Or are you waiting on me to do it? Either's fine. I'm just trying to sort this out.
I'm waiting on it right now.
Okay. 200 meters is all the way around. So all the way around is x plus pi d pi y plus x. So 2x plus pi. 200 minus 2x over pi. That in there, solve for x over y. Oh, just the I see. So the mistake here is that I did the area of the whole thing. They just want the area of the rectangular region. Okay, so I missed that. I thought they wanted the whole track there. So that nullifies some of the things I did here. Let me just cross out what we don't need. We don't need this, and we just need this. So that actually will, that's not needed. Let me take that out of my graph, and that should clean this up quite a bit. Yep, there it is. Okay, so let me get the appropriate window here for you guys. 0 to maybe 150 and 0 to, all right, let's maybe zoom in here. Okay, so I'm going to snip this in. You guys can see what I see here. So the window here that I used, and that's maybe the hardest part about using your calculator, is you got to get the right window. Your window would want to go from like 0 to, I went 0 to 150 to start.
Okay.
And then 0 to, it looks like 2000 is the right number to kind of get that nice fit there. But we only care about that point right there, that the peak or the vertex. And that's what they're asking for in part E. Okay, so the dimensions, and this tells you that x is 50. When x is 50, y, in this case, y represents the area of the rectangle. So that y value is the area. So it gives you the result there. Any questions on that?
Good.
You guys are okay. So it just to summarize here, because this is what you really care about. They're going to give you, you get a problem, and you generally have to write two equations, and then you substitute one into the other, and then you graph it. And then when you graph it, you're looking for that or that, either the max or the min. And so the next question, whatever it is, will be essentially the same thing. All right, so I believe that's 57. 57. All right, let me snip this in. All right. All right, it's 57. A manufacturer has a daily production cost of this, okay, to yield a minimum cost. So here, they're telling you, they're saying like, use the table feature of a graphing utility to determine how many fixtures will be. All right, so because of our lesson last week, I found a TI-83 emulator, so I'll be able to pull that up for you, I hope. Let's see here if I can get to it. Or yeah, because I guess you will need to do this on your side. For students, tools, TI-83. All right. So if you've got that, let's see if I can actually move that down here. Nah, that ain't gonna work. Okay, let me see if I can new share that. I don't know how this will work. All right, do you guys see a calculator on your screen now?
Yes.
Okay, so you're gonna go to y equals, you're gonna type in 800 minus 10x plus 0.25x squared. This one doesn't work. Nope. Huh. Delete. Okay, x caret 2. Okay, and you're welcome to either you're welcome to follow along, or I can wait till you get caught up here. So let me go. Should I proceed, or do you guys want to catch up?
I have it in my calculator.
Great. Okay, so the first thing I'm gonna do is graph it, and it's a syntax error. Great. 800. Oh, it didn't like that. So minus, and it's not gonna like that one over there either. All right, so there it is. We're gonna graph it, and we won't see anything, right? And maybe yours is better. So if you do a zoom fit, which is, where is it? Right there, zoom fit. It tries to give you a better window. Okay, but it's actually not very useful. Like, I don't know. I don't even know what that is. That just doesn't do anything for us. So we 800 minus 10x minus 0.25, no, plus 0.25. Sorry, that's why, plus 0.25. So it said to go to the table feature. So the table feature, if you go second table, okay, you get all these X values. And I don't know why they're having you do this, but like at some point you reach a minimum and then it goes back up. I guess you see it pretty quickly there. See at 20, it reaches a minimum, like 700.25 comes down to 700 and then it goes back up to 700.25. That's what they're asking you to do here. They're asking you to like find that place. Let me go to zoom fit again, see if we can do a little better job of fitting this. See, that's just terrible. Okay, let me change the window here. The window will be 0 to 40. You get rid of your scale. We'll go 0 to 800 here. Scale is 0, and let's see if we can get a little better graph of it. There it is. So there's some sort of a minimum right there at that minimum point. And if you guys have seen this before, you can do a second calc min. Okay. And then it asks for your left bounds. You got to go just a little bit left of it, hit enter, just a little bit right of it, hit enter. It says to guess, you always hit enter again, and it'll give us that perfect spot, that 2700 that we saw in the table. Okay, so again, they want you to use the table feature to find that. And all I did was I was just looking, well, y is going down, 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 and then it goes up, up, up. So that must be my place where that's a minimum of that. Before moving on to the next question, is there anything you'd like me to go over again on that?
No, I got it.
Was that Niko or Jamie?
Yeah, that was Niko.
I got it as well.
Got it.
Looks
Okay.
good.
Okay. Sorry. And I know I just, because I can't see, I just have to keep asking until you, I hear something like, yeah, let's move on. We're all good.
Sorry about that.
All right, next question here. So I'm going to go back to sharing my other window. The total revenue is given by this function here, okay? So revenue is like what you bring in, and they want the revenue when the price per unit is 20, 25, and 30. So basically they're saying put those values into the function there. So we can actually do that with the calculator. Do you guys gonna have a calculator part of your exam? Do you know?
I think she does no calc and calculators. Yeah.
Okay, so let's go back and so we're going to enter this equation into the calculator. So I'm going to go back to sharing that because we'll be able to use the table feature again with that. So share, go back to your y equals there. I'm going to clear that out, and instead of p, you use x squared plus didn't like that. Back to y equal plus 1200 x. Okay. You could graph this. I know that's the normal thing to do. You actually don't want to. You just want to go do your table, your second table. Okay. And we're kind of already there. So you just go down to 25 or 20 and you just read off the values. Now, let's say you didn't like that. You can go to second table set, which is the window here, and you can tell it to start your table at whatever value you want. Like maybe you want to start it at 0. And this delta means what to go up by. Now see how it's asking for 20, 25, and 30. So you can go up by 5, okay? And if you go to your table, you'll see that the X values are going up by 5. So you can just read off those 3 values. So at 20, it's 14,000. I'm putting this into that other screen, and I'll share that with you guys later, 13,500. So that's nice, but what if you needed like 20, 26, and 32 or 31, things that didn't go up by the same amount? So you can go back to your table set and you can actually change it instead of auto to ask. So if you ask and you go back to your table, you have to specify the X value. So you say, oh, I want it at 20, hit enter. Oh, I want it at 25, you hit enter. Oh, I want it at 80, whatever it is, hit enter. Okay, that's a bad one because that one actually doesn't work well. So a couple of options. It's like a lot of ways to do the same thing. Okay, so that's part A. Let's see what part B is. Find the unit price that will yield a maximum revenue. All right, so we need to graph this thing. So let's go back to let's do a zoom. Okay, let's do a zoom fit. Always try that one. Sometimes it gives you the window you want. Sometimes it doesn't. So that did pretty good. So we want that max up there. I don't know if you can see my cursor, but the max, I'm just kind of tracing it. And you want to do a second calc maximum. Okay, and it says left bound. So your left bound is always like left of where you think it is. It doesn't have to be that far left, but it needs to be left of the maximum. And then you just trace along the curve. I'm clicking that right arrow. You get somewhere right of it, hit enter, and it does a calculation that you don't care about, but it gives you the value there. So in your notes here today, what I'm going to show you is that you do a left, you do a right, and then you also guess at that point. This is for part B. And your maximum is at that point 24, 14,400. So part B is asking for the unit price, and that unit price is $24. Okay, and you can't use the table because let's just say it was at 24.50. Your table wouldn't see that, so you really have to use that graphing feature for it. Part C is asking for the maximum revenue. Yeah, it's like you have to be really careful there that use the right tool for the job. And I would always tell you to use the graph, not the table. But for some reason, that question before this one said use the table feature. All right, part C is saying what is the maximum revenue? That's the Y value. That's the 14,400. You get that from putting 24 back into that original equation. Part D says to explain the results. So let me go back to sharing that other window. They're looking for a sentence. They're saying interpret. You've probably heard that word before. And the interpret there is at a price of $24, the revenue is maximized at 14,400. So your instructor is looking for the words, and like this is the least you can do. They're looking for price, 24, revenue, maximized 14,400. The rest is articles or unimportant stuff. They're looking for this key information. Can you convert what you just did into a sentence? Like someday you guys might work for a company and the person you work for doesn't want to know all the things you did. They just want to know what the maximum revenue is, where it occurred, and what it is. So that you're kind of cutting through all the busy work to get to that final answer. Please let me know now if there's anything you want me to explain for this question again.
No, that all makes sense to me.
Makes sense.
Okay. Do you think you can do these on your own? That's really where this we're going to, and that's something to think about for this. These are all classic kind of problems you're going to see in calculus again. So if you get another shot, I guess, if this isn't clear. All right, so I'm trying to snip this next question in completely. All right. 91. Okay, so the picture cut off here a little bit, but basically you get another one of these and this. All right, so what they're saying, this question says, you want to make a box with an open top, which I think is weird. I mean, this is so unrealistic because if you guys ever order pizza, it doesn't come in a box like this, but that's how they always do it, the problem this way, but nobody wants an open box, but that's what you got. So they're saying like you cut a corner from each of them and it's the same there. All right. And then you've got 36 on each side. So like this whole length is 36 and this whole length at the top is 36. Okay. So this edge right here on the right here is 36 minus 2x because you cut both of those. And then this other edge over here, it's also 36 minus 2x because you cut both x's out of it. Okay, and you will see this problem, some variation of this problem. There's let's see, there's like fencing problems where you build, you got a barn and stuff like that, but you got an open top here. So your volume is length times width times height. And you already have all these. You can say that's my length, that's my width, and that's my height. 36 minus 2x times 36 minus 2x times x. So when you look at part A, and I'm going to snip it in here, it says to verify what we just said. And hopefully the visual here helps, seeing me kind of work through the steps here. You say, oh, I get it. That's the length, that's the width, that's the height. It's squared because there's two of them, and they just move the x in front. Okay, you will see this, so here's so sometimes they tell you like that you like what you might see differently in yours is like that number might change. There's a variation on this where they actually tell you, don't worry about that. That's probably not important to say. Okay, let's just keep going here. Determine the domain of the function v. You're like, well, why would I care about the domain? So when you graph this thing, it looks something like this, like it goes up. I think it comes back up again, but like what you only care about is this window here. And basically what you're trying to say is like, how big can X be so that this thing up here doesn't overlap on itself? Like, let's just say X is 10. That's good because 36 minus 2 times 10 is 16. No big deal, right? But let's say X is 20. Well, 36 minus 2 times 20 is -4. That's bad. Okay, so you're trying to figure out like, well, how much can you reasonably cut? Well, you can't cut more than half the length, because if you cut more than half of it from both sides, you run out of box. So like if you were to try and cut this right in the middle there at 18, you got two of those. You'd have 18 and 18. That's no good. Okay, so basically you're trying to figure out, well, what's reasonable here? And what's reasonable is anything from 0 to 18, because this means you have to make a cut. And this means your cut is less than half. (36 minus 2 times 18, that gives you 0, and x equals 0. So the domain is essentially like finding the zeros of this function. Okay, part C is to use the table feature. So I'm going to go back to sharing that. If anything is unclear, ask me now before I go to graph it. Otherwise, I'm going to go and graph this thing.
Yeah.
Okay, so you go back to your, turn it on, go back to your y equals, clear that out. And you do not have to expand. You don't have to simplify. You just type in 36 minus 2x squared. Where's my square? There it is. Okay, now if I graph, it's going to use the same window as before. So I generally go zoom, fit to try to get it to give me the window I want first. And I don't really like that window, but if you remember the picture I made, I showed how it kind of goes down and down. It goes down and then comes back up. Go to your window, and we said the domain is 0 to 18. So I'm going to go just a little bit past that. And this is where it's tough. I don't know how big to make the y, but that's too big there. So let me just guess 1,000. I'm just going to guess, and then I'm going to go graph it. So it went up, it went down. I need to make my window taller. And there's two strategies you can do here. The first strategy is to double and then go by 10. So either multiply by 10 or multiply by 2. I don't think that's nearly enough, so I'm going to go 10,000. That looks pretty good. It's still probably a little too high. So if I really wanted to impress my teacher here, I would probably change that to 10,000. I think you could still do this. You can divide by 2, and it'll do it for you right there in the calculator. Let's see if we can graph that there. Yeah, that's nice there. Okay. So now to find the max, you go second, calc, and choose max. You got to go left bound, right? So you can see me clicking, click, 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 click. You actually don't have to do that. You actually just have to choose a number left of it. So you can actually come down to the keypad here if you've got some idea and say 4, and it'll use 4. Or like you saw me do, you can click, 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 click to get rid of it. Now you can actually just get just right of it. You don't, I mean, you can go all the way over here if you want. I mean, it's up to you, but just get right of it. Okay. Or you can type a number. So like, I'll just type in 9, enter, and you always guess at the same place. And there it is. Now, sometimes you get 0.00011, or it'll say 5.9999999. You have to interpret that. You have to realize that is actually 6. It's not 6 point, whatever, 5 zeros and 2 ones. That's the calculator. It's doing some math, and it's got these things called registers that you don't care about, but it's got its floating point stuff where it's keeping track of things that don't matter. The point is to put down 6 as your answer, not 5 zeros 1 1, because your instructor will say, well, did you understand this? And if you understand that, if you really understand it, it's 6. Okay. Now I know I just realized that we did the part D, which is the graphing part of it. Okay. So we'll go back and we'll use the table now. So I'm going to get a table set, and I'm going to go to, I'm going to just go to auto for the moment. Second table. And you can see here at 0, you get a volume of 0. At 1, you get a volume of whatever. And look at these numbers in the Y. They're going up, 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 up. And then they come down. So you might reasonably think that it's at 6. We just confirmed that. Part C, x equals 6. And the volume is 3456. So we actually did both parts C and D. You may have to consult the screen recording to see those values if you didn't get them down. I did just put them in the notes that I'll send to you guys.
Yeah.
Okay, is that everything from the pages that you'd like to work on?
I'll look
Yeah.
through, but those are the ones that I noticed.
Fine.
But I'll look again.
I'll see if I can find something.
We've also got a question of the week we can do like last week, and that's up to you guys though. So take a minute or two and look, and
Okay.
I think I'm good for all problems.
okay. So your choice, guys. We can do the question of the week. We can stop here. It's up to you. You guys can also chat each other, text each other. It doesn't matter to me.
If Jamie doesn't have any questions, I'm fine doing a question of the week thing.
Jamie, where you at on this?
A lot of those were kind of my questions that we already did, and I'm
Okay.
just seeing if there's any more.
All right.
It's looking like I should be good.
Okay, so let's I've snipped in the question of the week here. It looks like a systems question, and it kind of is, but then you get to the answers and you realize, oh, it's a little bit more complicated than that because it's asking you about things that can happen with a point on 2 lines. So I'll set a timer here of 2 minutes, and I'll just check back with you guys, and then we can talk about this question together. But give it a go here for me, please. Okay, guys, so it's been about 2 minutes. this system, it has a couple of possibilities. So it's possible that, and let's just say this is equation 1 and this is equation 2, and I don't know which one is which, but it's possible that a point could be on one line but not the other, on the second line but not the other. It could be the solution, or it could be just out here wherever. And that's what this is testing here. Do either of you want to say your answer to this one?
Should we just like type it to you?
You can just say it out loud if you want.
I got A.
The answer is A. It is A. And we can talk about some of this language in here, but the point of this question is that you're never just going to get something as simple as just, hey, solve the system on a standardized test. They're always going to ask you to do something a little bit different, a little wrinkle on it. And you have to be very careful with the language, because I don't know how you guys interpret is not a solution to both equations. You almost need to look at it without the word not and decide, is it a solution to both equations? And then not means the other side of it. So are there any questions on this that you'd like me to explain? I can give you another one here also. Let me know what you need at this point.
I would be okay with looking at another question.
All right, let's do one more and then we can stop there. Let me grab this one. All right, so try and do this one in about 60 seconds if you can, please. All right, do either of you want to chat me your answer to check what you've got?
Sure.
What'd you say there? You broke out for me. Or broke
Yeah,
up there.
just if you could chat me your answer if you want me to check it. Otherwise, I'll give the answer out in another 30 seconds or so. All right, you both are correct, D, on this one. Okay, so good job. There's another variation on this question which asks which of the following is not a true statement about the point, and those are much harder. And you will see some variation on that either in this test or college where not a true statement. Here there's one true and 3 false, but in the not a true statement, let me not put it there. There are 3 true and 1 false. And that's the other possibility here. So, all right, a good session, guys. That's all I've got. Is there anything else you'd like to work on? We've only got a minute or 2 left here, a couple minutes left if we need it.
I think I'm good.
Yeah, I think I should be good too as well.
Great. I'll send you the notes and the screen recording out shortly. Thanks again for scheduling, and I'll see you next time.
Thank you.
Thank you.
Bye now.
Bye.
Bye.